Section 4 is about parallel lines and proportional parts. So in Section 3, when we were talking about similar triangles, we looked at the big triangle, or the outside triangle here as a whole, and we looked at the small triangle that was created by this parallel line that runs through the triangle. Okay, and that is how we set up our proportions. It was small triangle to big triangle, or big to small, either way. Okay, this section and this theorem specifically, the triangle proportionality theorem, says that if a line is parallel to one side of a triangle and intersects the other two sides, okay, so in this instance we've got BE parallel to CD, okay, so if that happens, then it divides the other two sides into segments of proportional length. So now instead of looking at the big triangle and the small triangle, we can just look at AB and AE and compare it to BC and ED. Okay? Those parts are now proportional. And we can set up a proportion that way. And the converse is also true. So if you know that these parts are proportional, then this line is parallel to that third side of the triangle. Okay, so some examples. If PS here is 12.5, SR is 5, and PT is 15, we want to find TQ. Okay, so we've got part, those parts correspond, these parts correspond. Okay, so we can say 12.5 over 5 is going to equal 15 over x, since ST is parallel to RQ. Okay, we cross multiply. 12.5x equals 75. Divide both sides by 12.5. And so TQ here is 6. Okay, go ahead and try example 2 on your own and check your work, check your answer in the completed notes.